On to Marc Herremans. As I said a few weeks back when I had to introduce Marc, we go back a long way to the first bird atlas in South Africa. Marc was the editor for Botswana, and even though that is 25 years or more ago, I can still ask Marc questions about stuff that relating to birds in Botswana, and he's got the answers at his fingertips. So thank you, Marc. So Marc, you're talking about Skinner traps tonight and all sorts of other things. I will just leave you to carry on. So Marc is talking to us from Belgium this evening. Thanks, Marc.
Yep, I'll be talking about two tools which have changed my citizen science involvement substantially over the last years. And that's a Skinner trap and image recognition. Now, this is pretty much a European experience, and we will later on maybe in the discussion see how much of it applies to Africa. There may be some things there that don't work, but okay, everybody knows that many nocturnal animals, and certainly including moths, are easily attracted to light, most particularly to the ultraviolet spectrum of light. And if you mount a lamp with lots of ultraviolet light and a sheet, then you can be busy for most of the night. Now, this is clearly from a tropical area. You don't get that much everywhere. But anyway, you have to stay up all night to look at your sheet and to see what you get and to study it. So somebody found a more lazy version of that, and that is the lamp mounted on a container to make it a trap, and that is called the Skinner trap. And it's lazy and easy because you plug it in the evening, you go to bed, and you see what's in there in the morning. So that's far more convenient to my style of sampling. Skinner traps come in all sorts of shapes, material, and even different types of lamps. The essence is that most of the lamps are sensitive to humidity. Particularly this one is a mercury vapor lamp. It gets hot when it burns, and when it gets splashed with rain, it explodes. So you need to protect it well. Another thing is that this should be slippery and steep so that the moths fall inside of the trap. And mercury vapor lamps need a ballast, which means you can plug them into the mains, but if the ballast isn't there, it blows in seconds. And so you switch it on in the evening, and in the morning, those egg cartons serve as a hiding place for the moths, and you can have plenty of moths in there, which are settled and quiet in the morning, and you can study them easily. That's in a European setting. On very warm summer nights, it happens that you open the trap and that moth starts flying out immediately because they are warm enough. So one point in the tropics that may happen as well. I have no experience, but probably there's a little problem there in some parts that have hot mornings or hot nights. You can put those anywhere you want, but if you have to put them in a nature reserve or so, you will need a generator because they run on main current. You can have several lamps on one generator, but then somebody needs to get up at night to refuel the generator. We use mercury vapor lamps, preferably the coated ones, because these give too bright light, which makes the neighbors become annoyed, and which may generate too many insects as well. But there are other options. For instance, you can have black light, which is a kind of tube light, actinic, and it's not that obvious to you. It mainly emits ultraviolet, but we find it far less, it yields far less moths than the mercury vapor. In recent years, people have made also UV LEDs. They are not so efficient either. even specifically the designed LePilet, but there is one advantage: you can run them a whole night from a single power bank. Now, there is one other problem with the mercury vapor lamps. They have been banned in Europe because they are not so environmentally friendly. It's a bit annoying if you have a monitoring network that runs for over a decade on that lamp, and now you have to change your gear. So if you want a monitoring network, think first what you're going to use and then go for the same equipment all over. I spoke about possible problems of having too many insects. Well, in Europe you have a few nights that the light attracts lots of beetles and sometimes wasps and things, and then the moths may get mulched up. That may happen more commonly somewhere in the tropics as well. It's a great educational tool, although you better switch off the light because it's not good for the eyes. But for instance, all our bioblitzes start with a couple of Skinner traps that had been all night. So you start off with dozens of species in the morning right away. It's a great educational tool. Children love to play with moths, certainly when they are spectacular. And if you find a number of people that can put it up in their garden or wherever, you can build quite easily a monitoring network because you can count the individuals as well. You can put it on a table to save your back and to avoid problems, for instance, with scorpions or with snakes. Okay, I have two of these in my garden, one in the woods and one more open in the veggie garden. And I operate these for about 100 to 200 nights a year for the last 13 years. That means that the BioBlitz for my garden over that time period is heavily affected by moth data. As you can see, there is 2/3 is over 100,000 records of over 500,000 specimens of moths. But it's still not boring because, if you can see, that generated over the years 947 species of moths from my garden. In fact, there is close to 2,000 species of moths in Belgium. This is a very species-rich group, and it's so easily sampled with just one system, that even while you sleep. So it's great for biodiversity sampling. And even with that number of species, I haven't got them all. And basically, because there's so many species sparse or even rare, every day you get nice new stuff and you get surprises. For instance, this year, this tiny little chap of 2 millimeters was a new one, not only for my garden, but also for the country. And even this one, our largest moth we have, showed up not only in my garden. We thought it was for decades extinct, but now doesn't show up. So apparently it is an erratic migrant rather than a species that was resident at the time. So new things all the time. If you find sufficient people to do a network, and you do it for a number of years, you can make monitoring trends. And evidently, or unfortunately, you have some species that decline strongly, like the buff ermine. You have others that arrive and that establish themselves. But most typically, there's many species that have those huge annual changes. Quite erratically, they just go up and down very strongly. Now, this chap is one of our commonest moths, and if you see that it changes so much in abundance from one year to the next, you know that for birds and bats, the food availability changes quite dramatically as well. There's other species that have clear cycles over several years, so you need quite a number of years of data before you actually know what's going on with that species. Based upon this series of data, you would say, help, it's going extinct. Just be patient. A couple of years later, it's back to normal. And then there is some species that do very odd things, like this chap. In 1 year, it was extremely numerous all over. The next year, back to normal. And ever since, it was normal again. Okay, if you want to see more of what you can do with a number of citizen scientists with that sort of trap, in terms of distribution and abundance and trends of moths, have a look at this webinar, which actually was a launch of the Atlas of the larger moths in the UK that happened a couple of weeks ago. On to moths itself. That book was about the larger moths, and generally moths are split into macros and micros. There is some taxonomic basis for it, but the simple definition is that the left-hand side, these are measured in centimeters and these are measured in millimeters. Back to the garden. This is for a number of years in different colors over the year, the number of larger moths per trap per night. And then you see that for a substantial number of nights in a year, you have several hundred moths. That's ideal. As soon as you get many hundreds, they start influencing each other. And if you are here at the bottom, less than 15, then it gets too boring to actually switch it on. When we go to the number of species, you see that you have, for most of the year, dozens of species. So that keeps it interesting. The little gap here in the data, we don't do that anymore now, but there was a time, once upon a time, people went on holiday during summer, as you may remember. Okay, do I know all those moths? No way that I can remember those hundreds of species, but we have a system and you take pictures and you upload them, and then sometime later, usually within minutes, administrators tell you what it is. And this little chap here, I caught in July 2011, and 6 years and 6 months later, the administrator found what it was. There were some other names suggested in between, but then that's the time it took before we finally knew. And that brings us to a new major step in citizen science, that's the image recognition. Since a couple of years, we've been developing together with Naturalis Biodiversity Center what is now commonly known as NIA, the Nature Identification API. And it is a deep neural network that recognizes pictures that has now been built into a simple app, OpsIdentify. You just take a picture and it immediately tells you what it is, as long as you have internet. It's also been built in the more complex mobile apps. As soon as you add a picture, you have the option for an ID. And it's also available on the website of observation.org, which is the platform we use. You upload the picture and he immediately tells you what it is. And we'll try to do a live demonstration of that. And now I have to switch things. I think I'm now live on the website. Let's see what happens if I upload. Do you see this? That's painted lady, well known in Africa as well. When I select that and I open it in the website, it loads and poof, it says, yes, I know that, that's 100% sure, a painted lady. Let's try a few more. A hawk moth. What does he make of that? Puff. Elephant hawk moth. Pretty sure about that, and he's right. Something else, a geometric. Whoop. Carpet, 100% sure. Let's try another one. One with less distinct marking. This one, for instance. Yep. Very sure, and is always right. Now, what else do we have? Here is a noctuid, not very distinctly marked, and a rare one actually. Would you know that one? Yep, in no time you get the name and 100% sure. Let's try some more, a very drab, indistinct thing. Bloop, 100% sure. So that goes easy that way. You just take pictures what you don't know, and in no time you get there. Let's find, this is actually a difficult group with dozens of very similar species. Well, it's not so sure, but still sure enough, and it is the correct one, I can tell you. And let's have a look at the uncertain predictions. Well, you find a couple of very closely related species. You can go on to these if you want to see them and so on. What does he make of micros, tiny little things? Again, with 100% certainty and the correct one. Time for another one. This is a very non-descripting, and again, right, spot on. Let me quickly go back here. You remember our chap that took 6 years and 6 months. I got it again this year in summer. Obviously, I forgot its name and I forgot that I had seen it before, but now just have a look at how long it takes now. This one. Poof, there it is, and it's spot on. So that's a little bit faster than 6 years and 6 months, I would say. Let me try something different now. This is clearly a little mushroom. Whoopee, he makes a toad out of it, or a ray, or a sea scorpion, which is a fish. What's going on here? Nia doesn't know. What does that mean? Let's try another one of the same thing. Now he makes a butterfly or a moth or a bug out of it. He hasn't got an idea. What's this? And let's try the third one of this. And again, he has no clue. Now that brings us to another law of knowledge. As soon as you know a lot, you start also knowing what you don't know. So if Nia hasn't got a clue what picture you show him, it actually starts getting interesting. As it turns out, this little mushroom is in my garden right now. Nia doesn't know. I've asked a number of people. And as far as we know now, it's actually a species new to science. I would never have followed it up if Nia hadn't said, I have no idea what this is. So while online platforms and mobile apps were major milestones in citizen science, the next and the real game changer now is image recognition. Because now everybody, you need just a slightly little bit of interest to take a picture and ask yourself, what is this? But everybody can participate now. And that's basically the message I wanted to bring tonight. Thank you.
Thanks, Mark. That was amazing. Questions for Mark?
Well, as a lepidopterist, sorry, I'm gonna jump in here. I'm gobsmacked. You know, we've been talking about AI for identifying butterflies and moths for some time. We've got a couple of people in Lepsoc, Benny and Andre Kutzer, who run a company that specializes in image recognition software, and they've been talking about what they call training and AI. And I know that iNaturalist has got some artificial intelligence because I put plants on there, and it's similar. Within minutes or seconds, they come up with an ID for the plant, which is usually right. And the question I've got for Mark is, how long did it take to train that artificial intelligence? Because then you've got to start somewhere, and to begin with, it's dumb, and then it gets cleverer, doesn't it? How long did it take?
We are now something like 3 years down the road. So we started 3 years ago with the first attempts, just one group of bugs, and see what it does. And then in the initial trials, you needed to know beforehand whether you were asking about a butterfly or a moth or a grasshopper. You needed to have that knowledge yourself. Now, as of today, and this was actually the new version that I showed you, it is recognizing over 20,000 species, all mixed. So you don't, whether you throw in a mushroom or a butterfly, he sorts it out himself. And whether it's a caterpillar or an image, doesn't matter. So it took a little bit of time, but all you need to start off with is first a good algorithm, and secondly, a clean set of pictures that are 100% certain, sure, correctly identified. As soon as there is errors in there, it starts going wrong. And I'm not saying that it's perfect, because you get the very odd things that show up and you say, how is this possible? Just don't ask, accept that sometimes technology goes wrong.
I've been in touch with some of the Indian Lepidopterist Society, and one of the guys told me that it's very commercial there. They've got people who actually own this software, and they want to sell it to people who do apps like me, large amounts of money, and they say that I think it's something like 900 species of butterfly in India, and they now reckon they can do 600 of them accurately, which I believe now looking at that. I mean, one of the problems we got here is we've got so many similar species that can only be told apart in the genitalia. So I don't know how they're going to do that.
Yeah, okay. If you can't see it, an artificial intelligence system can't see it either. Probably. There have been systems that see things that we can't. There have been systems that see individual differences between birds, for instance, or between animals that we don't see. But you can be sure if you can see it, then the system can see it if it's well trained. That's certain. But we have groups of species, of course, that are difficult, and then it's fair that it replies with saying this is one of this group, without throwing out the name and telling you, well, it's just a gamble. No, then you should train the system to step back if it's not certain enough and be certain about the genus level or so.
Well, that's what happens here. We get, the genus Leptotes, which has got 4 species of butterfly that you can only tell apart by dissecting the male genitalia and identify them on LepiMap as Leptotes split.
Sure.
And the app would do the same thing. Probably things like Aleades, coppers, or russets.
There is limits, but for the layman, this is a huge advantage. It saves me hundreds and hundreds of hours a year trying to find out what things are, and it saves our validators thousands of hours a year in not having to sort out things that are trivial. So they can now concentrate on those difficult groups and on those interesting things.
Well, you asked Les what a schlep it is with LepiMap. I mean, we've only got a couple of do the identification. And I try every now and again with moths. We've got a huge problem.
Same this side. I mean, we receive over 2,000 pictures of moths a day in summer. So just find the number of administrators to follow that up. And now we can do something like 90% automatically. And they only have to concentrate on the remaining 5%.
Mark, how many perfectly identified images of a species do you need to train the algorithm about?
That's quite of a secret so far, but we thought initially it was a lot. So we thought initially you needed 50 or so, but the latest thing we hear that for distinct species you only need a couple.
Well, you can have all my butterfly photographs, Mark, but you just got to get them to you somehow. This is a fantastic thing.
This is developed by Naturalis Biodiversity Center. Give them a call and see what we can reach.
Absolutely.
I mean, they are working worldwide on biodiversity, so they may be interested in setting up a project. Yeah,
I mean, I wrote a field guide to butterflies, which came out first in 2005, and we just done the latest edition now, and we developed an app from it about 2 years ago, which has proved very popular. But we're busy with a new what's the word, upgrade to it now, where we're upgrading the photographs and a whole lot of things. And when I heard about AI, I said to Strake, my publishers, can we do this? Now I know these people who are what's the word, dabbling in it in South Africa, and they've been very secret about what they're doing. I would love to have this, on my butterfly app, just simply to say to somebody, number one, do you want to get this identified, or confirmed via the biodiversity system, or also, do you want to upload it directly to LepiMap? I mean, Les, I've been talking about this for some time, having some sort of a direct link between the app and LepiMap, so people can use it in the field. Phones nowadays can take photographs. People can say, I know it's this butterfly, click, touch that one. They're already using it to gather data in the field. This could be a game changer. What do you think, Les?
It is a game changer.
Yep.
So we've actually, with Marc as our advocate, we've actually been talking to observation.org. So, I've just been letting it slide. So, Marc, you've given me the kick in backside that I need to galvanize me into action. Thank you, Marc.
Brilliant. Well done, Marc. That's a really, absolute, can't congratulate you enough for that. That is brilliant. Really.
Okay, thanks.
It was a great talk, Marc.
Yeah.
Ataza, what?
No, there is a question before we, but I want to say thank you very much, Marc. That was very, very nice to see. And now I think I will start. It's from all over the world, right? So I can upload records.
No, the system that we use has only been trained for the Netherlands and Belgium. Observation.org is a data platform that works worldwide. And the same image recognition is in there. So if you add a painted lady, which occurs all over the world almost, then he will recognize. If you add species from Africa, he doesn't know. I'm interested to see what he makes out of it. At best, he will know that it's a moth or a butterfly or not, but most likely he just gets it totally wrong. So that's the training part that needs to be done. And probably if once you go to tens of thousands of species, it's going to be worth first telling a system where you are in the world. So that first from your GPS reading or so, he realizes you're in Southern Africa and he connects to that bit of the data and the reference information, because obviously at some stage it can become too much to identify.
Yeah,
that's what happens with some of our, well, all of our difficult species where they're extremely similar. Is we usually say, well, where did you photograph it? Because quite often that is more significant than the actual markings on the butterfly. But I love that observation about sometimes it spots things we don't see. That fascinates me. And as you know, Lithium Map's already got thousands and thousands of identified, but certainly butterfly photographs and probably other moths as well.
Yeah.
I mean, observation.org could start off with that.
yeah.
Yep.
Okay, so the question is, sorry, I went. If you can upload more than one picture, if, for example, the characters are hidden at the underside of one specimen.
You can upload several pictures for one identification round. And well, if you only use one, then use the diagnostic one. Then use the one where you see the underside, for instance. But it can identify, or it can judge several species together or several pictures together. The system can handle a number of them.
Marc, is iNaturalist using observation.org?
No, it's not. It's not. They are quite separate systems, actually. iNaturalist is American-based and accepts worldwide records. Observation.org is European-based, Netherlands, and accepts worldwide record, but is strong, very strong in the Netherlands, Belgium, and some parts of Europe. And the rest of the world is the data are thin.
Okay. I will definitely use it in Europe then. Yeah.
Give it a try if you want to make pictures.
Yes. Okay, great. Thank you.
Are there any other questions? Yeah, the question is what happens in 3 years from now? Well, what happens in 3 years from now, pretty sure that you don't need the observer anymore in between. You just put a camera out and he sends directly names to a database. That's what's going to happen. And that will probably be the unfortunate evolution. That the fun part of the person discovering something will be the part that's going lost.
It's funny you should say that, because the bold people, the biodiversity life database, they have this dream of a handheld device that can read DNA from a single scale of a butterfly or a hair from an animal and it tells you not only what species it is, but where it comes from. That's the ultimate aim. Yeah. Given enough time, enough data, enough brains, it could happen.
Okay, and there is the last question that was missing. It's in Facebook. And it's how the system copes with those species that exhibit continuous variation rather than one or a few morphs.
I don't know whether we have many of those in Europe, but we have some of the ladybirds have at least 10 or 15 different forms, and he recognizes each of them as a separate thing, but gives them the same name. So he basically recognizes all the forms and then refers that back to the same name. So he can handle it. And that's the way he handled, for instance, a caterpillar and a butterfly of the same species. He recognizes both as belonging as forms of the same and gives it the same name.
That's where that location information is going to come in handy as well.
Sure. Sure.
Great, team. I think we're a little bit into injury time now, so I think we're going to call it a night on a